So now let's talk about what it means for one of these functions to be smooth. So the definition, the parameterization of the curve represented by the vector valued function R of t, which is f of t I plus g of t j plus h of t k. We're going to say it's smooth on an open interval I when f prime, g prime, and h prime are continuous on I, and also r prime of t is not equal to the 0 vector for any value of t in the interval I. So all of your component functions have to be continuous on your interval, but more than that, your derivative can't be 0 as well. So let's look at a problem where we're discussing smooth. We'll find the intervals on which the epicycloid C given by R of t, it's going to be 5 cosine t minus cosine of 5t I plus 5 sine t minus sine of 5t j, and t is between 0 and 2 pi, is smooth. So we need to find the derivative of this vector valued function. Let's start there. The derivative would be minus 5 sine t plus 5 sine of 5t I plus, it'll be 5 cosine t minus 5 cosine 5t j. And so these, we want to know where these functions continuous. Well, if we look up their pieces, these are both made up of sines and cosines. These functions are continuous over the whole number line. So the only problematic spots I've got to worry about is where is the derivative equal to 0. 0i plus 0j. So I'm looking at setting my first component function equal to 0, and then my second component function equal to 0, and I want solutions to this system of equations. So I have a system of equations here. If I solve, let's take and solve these, you'll get sine of t equals sine of 5t, and you get cosine of t equals cosine of 5t. And remember that t is restricted between 0 and 2 pi. So if you look for solutions to this, you get the only solutions are t equals 0, pi over 2, 3 pi over 2, and 2 pi. I'm forgetting one. Actually, there's also pi. So it's pi, 3 pi over 2, and 2 pi. So then everywhere except for those values, my function will be smooth. So let's convert that into intervals. It'll be smooth on the intervals. 0 to pi over 2, not including those. Pi over 2 to pi. Pi, 3 pi over 2, and 3 pi over 2 to 2 pi.